Okay, so we're going to talk about what is called the transversal of parallel lines. To start off, parallel lines are going to be any two lines that will never touch, and they are denoted by the symbol. You got these little arrow symbols in a line. That just means that those two lines are going to be parallel. Before we can talk about anything in terms of measure with angles, we need to talk about some terminology. And it's pretty simple terminology. The two key, well really there's three key, let's make it four. There's four key terms we have to understand what we're talking about when we say them. The first two are interior and exterior. And this is a pretty good visual of interior versus exterior. And it's probably what you think. Interior is going to be all of this space that is on the interior of these parallel lines. And it would include any of the angles that you see here in red. Now exterior, as you could have guessed, would be anything on the exterior of the two parallel lines, which is going to be one of those four angles there. So our interior and exterior are pretty simple. The other thing that we talked about, or I said there's going to be four terms. The other one's up there. It's called the alternative or alternate sides. All that means is that we're talking about opposite sides of the transversal. This line here is going to be the transversal. So opposite sides would be here and here. They're on opposite sides of that transversal. Or you could say opposite sides are going to be here and here. They're on the opposite side of the transversal. And if that's what opposite side means, I'm sure you could deduce that same side just means they're on the same side of the transversal. Same side of the transversal. I'm going to make this one blue so we can see which two I'm talking about. The blue ones are the same side, the black ones are on the same side. So that's what we mean by interior, exterior, same side, and alternate sides. We have a couple different postulates, theorems, whatever you want to call them. A couple different things that can make our lives a lot easier. The first one is alternate interior angles. And what this tells us is that alternate interior angles are equal in measure. And let's break it down to really the two base words. First one's going to be alternate, which remember we just talked about means they're on opposite sides of this transversal line. So our alternate sides would obviously be anything on this side and anything on this side. That would be alternate sides of that line. And when we talk about interior angles, we're talking about any angles that are on the inside of the parallel lines. So on the inside of the parallel lines, I have angle 1. The alternate interior angle to that is going to be over here. So it's on the other side of that line. 1 and 2, since they're alternate interior angles, they are going to be congruent, which means they're equal in measure. And now 3 and 4 are also alternate interior angles. They're on alternate sides of this transversal line, and yet they're still on the interior of those parallels. And this allows us to solve, because we can use that fact that we know that alternate interior angles are congruent to solve for angles. If I know that the measure of angle 3 is 150 degrees, I can label that here. Angle 3 is 150 degrees right here. Right? I can use the alternate interior angle theorem to tell me what the angle of, or the angle measure of angle 7 is. Since I know they're alternate, remember on the other side, opposite sides of this transversal, and I know they're interior, which means they're in between my two parallel lines, then I can say angle 3 is going to be congruent to angle 7, which means my angle of measure 7 is just 150 degrees. And again, that's my alternate interior angle theorem. My alternate exterior angle theorem is exactly the same, but now we're talking about the exterior of the parallel lines. So angle 3 and angle 4 are both on alternate sides of this transversal, and they're also on the exterior of the parallel lines. So angle 3 and 4 would be equal. And I can say the same thing about angles 1 and 2. 1 and 2, they're on alternate sides of this transversal. They're both on the exterior, so I can say that measure 1 and measure 2, measure of angle 1 and measure of angle 2 are equal as well. And if I look down here, I can do the same thing. I can solve a problem just by knowing this. So if I know that the measure of angle 1 is 30 degrees, what the alternate exterior angle theorem tells me is that the angle who is alternate, which means, remember, we're on opposite sides of this transversal, and exterior, so on the exterior of these parallel lines, is going to be equal to angle 1. And I know that this is going to be alternate, which means opposite sides, and it's also on the exterior of these angles. So measure of angle 1 is going to be equal to the measure of angle 5. So I can say that angle 5 is going to be equal to 30 degrees. And I know that, and I can prove that by using the alternate exterior theorem. As we continue on, we can talk about corresponding angles. Corresponding angles, if I would cut this transversal right at this line and I would set this on top of this point, my corresponding angles would be the angles that lined up perfectly. So I can see that angle 7 and angle 8 are corresponding angles. They're in the same part of that transversal there. I can also see that angle 1 and angle 2 are corresponding angles. We'll go through the whole thing. Angle 5 and angle 6 are corresponding. And last but not least, angle 3 and angle 4 are corresponding. What that means here is that all of those corresponding angles, the measure of those angles, are going to be equal. So let's look at an example here. If I've got measure of angle 3 is 150 degrees, so this one is 150 degrees, and I'm trying to find what angle 6 is. I can see here that angle 6 and angle 3 are corresponding, so that's simply, I can say it's 150 degrees, just because they're corresponding angles. So that allows us to find yet another measure angle. And if we continue on, same side interior angles. Now this one's a little bit different. It doesn't tell us that they're equal. It tells us something different. So if they are on the same side and on the interior, same side. So interior would be here. Same side, it's going to be over here. I can look at 3 and 4. I can say that 3 and 4 are same side interior. And what does that mean? That tells us here that they are supplementary, which is a geometry vocab word, buzzword. All that means is that those angles add up to 180 degrees. So angle 3 plus angle 4 is equal to 180 degrees. And that's the same thing for angles 1 and 2 here, because we can see they're on the interior of my parallel lines. They're on the same side of this, same side of the transversal. So I can say they're same side interior, which means angle 1 plus angle 2 equals our 180 degrees. And that's useful as well as we're solving. And you'll see right here. So I've got the measure of angle 3 is 150 degrees. Now I'm looking for this angle here. So I'm not sure what angle 2 is. I can look at that and I can see that because of this relationship, they are both on the inside or the interior of these parallel lines. They are both on the same side. I can say that they're same side interior angles, which tells me that the measure of angle 3 plus the measure of angle 2 is supplementary, which means they're equal to 180 degrees, which means they would create a straight line. And if I'm looking at that here, I can just plug in some numbers and solve. So I know here that the measure of angle 3 is 150, so I've got 150 degrees plus the measure of angle 2 is going to be equal to 180 degrees. And now simple algebra takes over. I subtract 150 on both sides, and I get my measure of angle 2 is equal to 30 degrees, and that's proven by the same side interior theorem. And as we push along, we've also got vertical angles. Vertical angles are a little bit different. Vertical angles just show us a relationship of our angles here, and I like to think of it as our opposite sides of an x. So if you look at angles 1 and 2, they're on the opposite side of this x here. Here and here. So those two are going to be congruent. Same thing's true about 3 and 4. They're on the opposite side of this x. And now down here we've got a similar x, and we can say 7 and 8 are going to be congruent, and 5 and 6 are going to be congruent, and those are called, again, vertical angles. And to solve for a vertical angle, we just have to apply what we know. So we can say, if we know the measure of angle 3 is 150 degrees, and we're looking for this angle here, this angle 4, we know that these two are vertical angles. If I look at this x here, they're on opposite sides of this x. I could say that they're vertical angles, and the fact that they're vertical angles tells me that the measure of angle 4 is going to be the same as the measure of angle 3, so both of those is going to be 150 degrees for my vertical angles. And the last thing I got here, the last one we'll talk about is going to be our linear pairs, which is just a fancy way of saying we have a pair of angles that creates a line. So 1 and 2, we can see angle 1 plus angle 2 is going to give me this straight line. Same thing for 5 and 6. I've got 5 and 6. They're going to give me this straight line here. So I've got one more example here of how we're going to solve here. So angle 3, we're back at it, is 150 degrees. Now I'm looking for this missing angle here. This angle 1. Well, I know that angle 1 and angle 3 create this linear pair, or this straight line. So I can say the measure of angle 3 plus the measure of angle 1 is going to give me 180 degrees. Again, we're just plugging in for 3 over here. For 3, I would have 150 plus the measure of angle 1 equals 180 degrees. Simple algebra again. I subtract 150 and I subtract 150. I'll get the measure of angle 1 is 30 degrees, which is proven by this fact that linear pairs are equal to 180 degrees.